Embryology. HOD sir अच्छे रहेंगे. Embryology.
Hello students, good afternoon.
Good afternoon.
Good afternoon, sir.
What happened to morning class? Have you attended or not?
Yes, sir.
Yes, sir.
Huh? Number 1 is there. Number 1, 2, 4, 7, 8, 10, 11, 12, 14, 16. Anyone of you is there? Number 1. Number 1. Number 1, 2, 4, 7, 8, 10, 11, 12, 14, 16, 17, 18, 20, 21, 23, 24, 29, 30, 31, 33. Please, any one of you here?
Yes, sir.
Yes, sir.
What happened in the morning class? Have you all attended the class or not?
Yes, sir.
Whoever I called now,
Yes, sir.
Yes, sir.
only 0 minute is there. Huh? You are all attended less than a minute. Huh?
No, sir, actually.
Now you still, I will read the number. 1, 2, 4, 7, 8, 10, 11, 12, 14, 16, 17, 18, 20, 21, 23, 24, 29, 30, 31, 33, 34, 35, 36, 38, 42, 43, 44, 45, 46, 47, 48, 50, 51, 55, 56, 62, 63, 66, 67, 70, 71, 72, 73, 74, 75, 76, 80, 81, 82, 83, 90, 95, 97, 98, 99, 100, 103, 106, 107, 112, 113, 116, 117, 118, 120, 122, 128, 136, 139, 141, 143, 144, 145, 149, 150. MSc Anatomy 1, Biochemistry 1, 2, 3, 4, 5, 6, 8, Micro 3, 5, 7, 9, 10, 12, 15, 16, 19, Physiology 2, Swabada. You people are attended less than a minute, I don't know why.
Sir, we attended.
Sir, we attended the class, sir.
Sir, we attended.
We attended 2 classes.
Sir, we attended the class.
And most all of us are video were on only, sir.
Our videos were also on, sir. Sir.
I don't know whether your video were on or off, but your time of duration of your attendance is less than a minute, it seems. Developer less than a minute. 0
That
minute.
is because we are a work at hostel, sir.
Below 10. Less than 10 minutes, it seems.
Sir, in the middle, it might have got disconnected, so it might show like that.
Pardon?
In the middle, my computer got disconnecting with the Zoom call, sir. So it might. I'll keep reconnecting every time.
Then okay, that is
So
number
maybe-
12. What about others?
Excuse me, sir.
Sir, we attended.
Total password, sir.
Please, one by one. Talk.
Sir, 127, sir. My screen kept freezing. I had a very bad internet connection today, sir.
Uh,
I attended the class, sir.
so 127.
Sir, roll number. Sir, sir, I got spice in the class, sir. I attended with my roommate, and even for Ashma ma'am, I said that like I have network issues, so I'm attending with my roommate. Even our video was also on, sir. Means I logged in thrice, I think, today, but most of the
115,
time I
okay, you
attended.
are 115, your number is not there.
Sir, 103, sir.
103 is there.
Sir, I attended the video. I attended the meeting, sir.
But what,
Video on,
whatever
sir.
number I called out, your duration of attendance is less than 10 minutes, it seems. Anyway, I'll ask the clerk to check once again. At the end of the class, we'll discuss about it. No, the check panel. What about PG students? Priya,
Yes, sir.
have you attended or not?
No, sir.
You didn't attend.
Yes, sir.
Why?
Sir,
Sir, I'm not well, sir. That's why I didn't attend, sir.
What about other MSCs?
sir, this is Ruben from biochemistry, sir, roll number 5. I have attended the full session, sir. I have attended the full session. Sir. I don't know
Anyhow,
why.
I asked her to check once again. We'll discuss about it at the end of the class.
Sir,
Okay,
this
okay.
is Monica from MSc Medical Biochemistry, sir. I also attended the whole section, sir.
That what may be the reason for that? The attendance is coming like that. You people attended less than 10 minutes. I think almost half of the class attended like that. Means remaining half only attended the class, it seems.
Sir, even the video was turned on for the whole hour, sir.
Yes,
I don't know why.
That madam used to tell about it, but madam didn't tell anything about that video or any other thing. Only clerk used to check the attendance.
Sir, you could check the recording, right, sir?
Sir,
Recording,
Sir, we even answered, sir.
Yes, sir.
sir.
We answered also, sir.
We all.
Sir, actually, what happened is like the light in the hostel, sir, it was going out continuously, sir.
power,
And sir, the Wi-Fi wasn't working for half an hour approximately, sir.
Wi-Fi. What we're telling is Wi-Fi is not continuously coming.
Sir,
we had a
the
power
lights
cut in
went
the
off, sir, in between.
Power went off.
System,
Yes, sir, yes. Between 2 or 3 times the lights went off, so that might have disturbed the server, I guess, sir. Must be some technical issue, sir, because most of us were present throughout. We also had our videos turned on, sir. You can ask ma'am also.
Anyway, I will check with that recording.
Yes, sir.
Is it getting recorded now?
Yes, sir. Yes, sir.
Yeah, I am not getting that signal. Okay, students, last class we have seen about the development of interventricular septum Before that, we have seen about the development of atrial septal, interatrial septum, and the atrial septal defect. Like that, here you should know about the ventricular septal defect. So, what are all the structures contributed for the development of interventricular septum? The main ventricular septum, actually, basically, if you take your interventricular septum, it is having two parts. Membranous, upper part is membranous, lower part is muscular. So two components are there. So the muscular part is derived from that interventricular septum, that is getting originated from the floor of the common ventricular chamber. So from the floor of the common ventricular chamber, we are having development of a septum, that is a continuous septum that only forms the muscular septum. So above that you have an interval. So that interval between your septum intermedium and your interventricular septum, so that foramen is called as interventricular foramen. Interventricular foramen. So that small part of interventricular septum is formed by the proliferation of your AV cushion, that is your septum intermedium. Note that point, your septum intermedium is involved in the development of interatrial septum as well as interventricular septum. That point you have to keep it in mind. So if there is any defect in the formation of AV cushion, otherwise called as septum intermedium, there is chance for the defect in the atrial septum as well as ventricular septum. So that point you have to remember. So if you see this pink one, so that is for understanding purpose, it is given as given in pink color. So this interventricular foramen or upper part of the your interventricular septum is formed by the proliferation of this AV cushion. So that proliferated AV cushion will join with that interventricular septum what is formed already from the floor of the common ventricular chamber, and little bit descending down of bulbar septum. So the bulbar septum is nothing but, already you know that during the development of the ventricle, your conus part of your fused endothelial heart tube so this is the your bulbous cordis, proximal part is conus, distal part is truncus arteriosus. So this conus will be absorbed into this ventricle. So that is the basic. So that conus on the right side gives rise to infundibulum, left side it gives rise to aortic vestibule. Aortic vestibule. So both are derived from this conus. So that will be separated by a septum called as bulbar septum. That is otherwise the lowermost part of your spiral septum, what we are going to see next. So that will separate your infundibulum and aortic vestibule. So remaining interventricular septum separates your right half and left half of the primitive ventricular chamber. So the primitive ventricular chamber gives rise to both right ventricle and left ventricle. So they are getting separated by the formation of interventricular septum. So that interventricular septum only we are reading now. But if a very small part of the interventricular septum is formed by the descending down of the bulbar septum, that divides the your infundibulum and your aortic vestibule. Now you see, so here this AV cushion or septum intermedium is getting proliferated. So filling this interval, at the same time little bit descending down of our bulbar septum closes the interventricular foramen. So this upper part of your interventricular septum is called as membranous part, that is formed by the descending down and the fusion of your septum intermedium as well as by the fusion of septum intermedium with interventricular septum. So that's why the ventricular septal defect is always common in the membranous part only. So the ventricular septal defect is very, very rare in this your lower part, or otherwise in the muscular part. So the muscular part is entirely derived from the ventricular septum that is getting originated from the floor of the common ventricular chamber. So this is one component. Another upper part is the membranous part that is mainly formed by the proliferation of septum intermedium. So that the proliferated septum intermedium fuses with interventricular septum as well as above your bulbar septum. So that is the development of your interventricular septum. Once that complete interventricular septum is formed, so that common ventricular chamber will be divided into two, right half and left half. Right half forms your right ventricle, left half forms your left ventricle. Now ventricular septal defect. So here only one type of defect we have, not like your atrial septal defect. Atrial septal defect we have ostium primum type, ostium secundum type, and pattern foramen ovale. Pattern foramen ovale. Three types we have, but here we have only one type, that is in the your membranous part. The ventricular septal defect is there always in the membranous part. See that? So this is the defect. So this is the muscular part. So this is the membranous part where we have the defect, that is ventricular septal defect. Okay. So the reason for this ventricular septal defect may be failure of proliferation of your septum intermedium or descending down of bulbar septum. Both may produce this ventricular septal defect. So this basis is important. What is the basis for the, or embryological basis for the ventricular septal defect in the membranous part is important. So for that you should know what is the development of membranous part. So the membranous part is developed by the proliferation of your septum intermedium, or otherwise called as AV cushion. So all the times I am telling both, you should not get confused, that's why. So septum intermedium or AV cushion, both are same. So proliferation, failure of proliferation of AV cushion or descending down of bulbar septum may lead to defect in the membranous part of the interventricular septum called as ventricular septal defect. So one more point on the day I explained. So this also already explained. So see here you are viewing both interventricular septum here. This is interventricular septum. So what is this?
Septum primum.
Very good. Septum primum, because it is attached to septum intermedium. So this is septum secundum. This is septum primum. This is septum intermedium or AV cushion. So this is your interventricular septum. This is your bulbar septum. Bulbar septum. Now that your interatrial septum meets your septum intermedium. Interventricular septum also meets your septum intermedium, but the meeting point is not at one single point. Your interatrial septum meets little bit left, your interventricular septum meets little bit right. Because of that, this small part of septum intermedium that forms your interventricular septum separates your left ventricle and the right atrium. So that you can make out in the next picture. So this small part of your interventricular septum derived from septum intermedium separates your left ventricle and the right atrium. So that is very, very small part. Otherwise, this may your interventricular septum separates your right ventricle and left ventricle. So now the outflow tract of left ventricle is the your origin of ascending aorta. So ascending aorta is getting originated from here. So on the day I told about torus ioticus. Torus means elevation, torus ioticus. Can anyone tell about it? What is the torus ioticus? Anyone please come out?
Elevation in the
It is
right.
a elevation.
Region in the right atrial septum.
Posterior sign of the ascending aorta.
Anyone? Yes, number 22. Yes.
So it is an anterior anteroposterior elevation, sir. Bulging of the right posterior.
Where is it?
Right posterior
Right
sign of
atrial septum.
It is in the right atrium. That is important. Anteroposterior elevation present in the right atrium. It is produced by non-coronary aortic sinus. Okay, so how we are getting that elevation produced by the non-coronary aortic sinus? So that is present on the left ventricle. How we produce the elevation on the right atrium means this is the reason for that. Okay, if you understand, it is well and good. Otherwise, you leave it. Don't bother much about your torus ioticus. Okay. So now you see the small video partitioning of the ventricle first. So you concentrate the ventricle. Of course, simultaneously we will be having formation of interventricular interatrial septum also. So this is the muscular part of the interventricular septum. It is getting originated from the floor. Now this is the interventricular foramen that is formed by the closed by the proliferation of the septum intermedium as well as descending down of bulbar septum. So that is the what you are seeing now is the development of, so this is your primary interventricular foramen. It is fused by the proliferation of the septum intermedium only. Now you can make out that how that membranous part here it is formed by the descending down of bulbar septum and the proliferation of AV cushion. See that? Yes, very nice, very nice. So bulbar septum is descending down. Here that proliferation of AV cushion leads to formation of your membranous part of the interventricular septum. Once again, view the same. Concentrate this part. Yes, descending down of bulbar septum. Proliferation of septum intermedium, that is your AV cushion. So that is a formation of your membranous part of interventricular septum. There only your septal defect is more common. So that is ventricular septal defect. Both are very important short notes for you. Atrial septal defect, ventricular septal defect. You should be able to explain the embryological basis for both. So now we have seen about the development of both atria, development of both ventricle. So what happens to sinus venosus? What happens to your conus cordis? So now important point is the another septum. What you have to know is the septum that is separating your conus and your truncus arteriosus. Already know that what are all the structures derived from your truncus arteriosus. So that is the arterial end of the your fused endothelial heart tube. So the truncus arteriosus gives rise to ascending aorta and pulmonary trunk. So yesterday in the practical you would have seen both your pulmonary trunk getting originated from right ventricle, ascending aorta getting originated from the left ventricle. You would have seen. You should be able to recollect this relation. So what is this surface of heart is called as?
Sternocostal
Sternocostal surface.
Very good, sternocostal surface. So right to left, right atrium, right ventricle, left ventricle. So very small part of left atrium. Here see the relation between ascending aorta and pulmonary trunk. So this is your right ventricle. From this we are getting our pulmonary trunk. Now this is your left ventricle. From this we are getting our organ of ascending aorta. So what is the relation between your pulmonary trunk and ascending aorta here?
Pulmonary trunk passes anterior
to the aorta.
over anterior.
Pulmonary trunk is anterior. Your ascending aorta is posterior. So in this view, at that particular level, at the level of root of your pulmonary trunk, you can't make out your ascending aorta. Why means it is posterior. So here this pulmonary trunk is anterior, ascending aorta is posterior. So here the orientation of that spiral septum is coronal. It is already you know that coronal section means that will divide the body into anterior half and posterior half. Now you see this septum. So this is the part of septum separating your pulmonary trunk and your ascending aorta. So it is coronally oriented. The septum is coronally oriented. So that's why pulmonary trunk is anterior. Your ascending aorta is posterior. At the same time, if you go little bit up, there you see this is your ascending aorta, this is your pulmonary trunk. So this ascending aorta is on the right side, your pulmonary trunk is on the left side. So this is the next level. So one is on the right side, the other one is on the left side. So at this level, the septum is oriented sagittally. So that's why one is on the right side, the other one is on the left side. So at this level, you should be very careful. What you have on the right side is ascending aorta. What you have on the left side is pulmonary trunk. So that's why while giving your spot test, you should be very careful. If it is at this level, it is infundibulum. In this level, it is pulmonary trunk. At this level, what you have on the right side is ascending aorta, left side is pulmonary trunk. So here the orientation of septum is sagittal. If you go little bit up, if you see your arch of aorta here, you see here the ascending aorta is forming your arch of aorta. At this level, once again, your pulmonary trunk goes behind. So once again, anteriorly we have aorta, posteriorly you have your pulmonary trunk. So here once again, one is anterior, other one is posterior. So that's why the septum is oriented coronally. So in the lower part, it is coronal. One is anterior, other one is posterior. Next, in the middle part, it is sagittally oriented. One is on the right side, other one is on the left side. Once again, if you go up, once again, it is coronally oriented. So one structure is anterior, other structure is posterior. That's why this septum is called as spiral septum. As it is spirally oriented, it is called as spiral septum. To understand that orientation of spiral septum, this relation is important. So day after tomorrow, once you come to dissection hall, try to find out this relation. Okay, so in some of the heart, it will be along with ascending aorta, your arch of aorta. In most of the heart, you can make out ascending aorta and pulmonary trunk. So that's why in this part, you should be careful. In the little bit higher level, your ascending aorta is on the right side, your pulmonary trunk is on the left side. So for both, we will ask the branches only. So suppose if we keep pulmonary trunk, give its branches. Yes. Yes, students, what are the branches of your pulmonary trunk?
Right and left pulmonary arteries.
Right and left pulmonary arteries. So right and left pulmonary arteries are branches of your pulmonary trunk. Keep it in mind. Now I am telling about development of pulmonary trunk only, not pulmonary arteries. The development of pulmonary artery is important. So that word pulmonary trunk pulmonary artery. Carefully, you have to note in the MCQ also. So under the content of root of the lung, can you enumerate what are all the contents of or structures passing through the root of the lung? Number 150.
Pulmonary artery,
Anyone. I don't want this to chorus answer. 150.
Bronchus, pulmonary artery, pulmonary veins, bronchial arteries, pulmonary
150,
plexus.
150.
Yes, sir.
150 is there or not?
Yes, sir.
Yes, tell. What are all the structures passing through the root? Yes, come on. Root of the lung is there or not? Is there any terminology called as root of the lung or not? 149.
Yes, sir.
149. Yes, you gonna.
Yes, sir.
Root is there, isn't it?
Yes, sir.
Hilum is there or not?
Yes, sir. Hilum is there, sir.
Both are same or different?
No, sir. They're different, sir.
Very good, very good. They are different. Yes, give me the content of your root of the lung.
Sir, it differs in both the lungs, sir. Right lung we have one bronchus. Sorry, right lung we have two bronchus. Left lung we have one bronchus, sir. And
root content.
Okay.
I am telling.
Okay, sir.
At the level of root, there is no difference.
Okay, sir. Sir, so
yes.
Pulmonary artery, sir.
Pulmonary artery, very good. Not pulmonary trunk. Keep it in mind. Yes, next.
So then pulmonary vein, sir.
Of course.
Superior and inferior pulmonary vein. And
very good. Next. Next is also important for your MCQ.
Bronchus.
Bronchus. Which bronchus?
Principal bronchus.
Principal bronchus. That is important. So instead of principal bronchus, we may give trachea or secondary bronchus, tertiary bronchus, like that. Like that, in the place of pulmonary artery, we can give pulmonary trunk. So that is important for MCQ. So name the structure that covers all the structures passing through the root.
Mediastinal pleura, sir.
Very good. Mediastinal pleura. It hangs down to form what? Number 150?
Pulmonary ligament. Okay, sorry, sir.
Number 150. Mediastinal pleura covers the contents of the root. After that, it hangs down to form what? 150. Number 150. 150 is there in the meeting or not?
Sir, her mic is not working, it seems to.
Yes, 133. 133.
Yes, sir.
Where mediastinal pleura covering the root of the lung hangs down to form what? That is another important spot as for you. Already lung you have seen. Teacher would have told that is very important spot as for you. Yes, ma'am. You can't understand. You can't understand. Okay, leave it.
Pulmonary
Number
ligament.
150.
Pulmonary ligament, sir.
It is pulmonary ligament. So formation of pulmonary ligament is by mediastinal pleura, or it is otherwise parietal pleura. Am I correct?
Yes.
Nothing is there in that to understand. Mediastinal pleura, after covering the contents of root of lung, it hangs down to form what? That is the question. 133. And nothing is there to understand in this. If you know, you can answer. Otherwise, you can't.
Sir,
answer.
I couldn't hear you.
Am I audible or not? Hello, students.
Yes, sir.
Yes, sir.
Audible, you know?
Yes, sir.
Yes, yes. Clearly, I am audible. Okay, leave it. So, next question: what is the function of this pulmonary ligament?
Sir, it provides in the expansion of
It provides dead space. So that word is important. It provides dead space for the engagement of the pulmonary veins, during the venous return. So very important spot is for you. Okay, pulmonary ligament. Okay, so now we will go to the spiral septum. So the spiral septum separating your ascending aorta and pulmonary trunk. Of course, small part of your conus also, where infundibulum and your aortic vestibule. So tomorrow, day after tomorrow, in the dissection, you have to see the interior of right ventricle, interior of left ventricle. Of course, interior of right. Is it over? Interior of right atrium?
Yes, sir.
Yes. So right ventricle and left ventricle, you have to see. Try to find out your infundibulum. The corresponding to infundibulum, we have aortic vestibule on the left side. That only you have to put your finger inside on the left ventricle. You have to feel for it. You can see your aortic vestibule like your infundibulum. So that you keep it in mind. So that is very, very important point. You should be able to identify the trabecular corneae, your papillary muscle, cusp. That and all very important. So unique chance you are getting, please try to see all those things. So in the right atrium means definitely you have seen about the anterior out part, posterior smooth part. What are all the veins opening into it? Crista terminalis and all. So already embryology over. Try to recollect while seeing your gross anatomy parts. What is the development of your crista terminalis? What is the development of valve of IVC? What is the development of your coronary sinus? And all you have to recollect at that time. So hereafter, as you have completed gross anatomy of heart, development embryology of heart, don't allot separate time for reading embryology and your gross anatomy. While reading gross anatomy, you have to read your embryology, corresponding histology also for some other structure. So you are reading about lung means everything you have to read. Development of lung, gross anatomy of lung, your histology of lung. So like that, if you read only, you can understand your basic things. So you can retain the things. Don't allow separate time hereafter for gross anatomy, histology, embryology like that. Are you clear, students? So now you are in the second part of the year. So almost most of the topics will be over. So you have to read like that only. Don't separately read histology, separately gross anatomy, separately your embryology. So in that way only you have to read. So now you see these two pictures, you can understand that. So here you can't understand anything. So clearly, if you concentrate the arrow, so this is coming from right ventricle. So infundibulum and your pulmonary trunk. This is coming from left ventricle. So this is this arrow denotes aorta. Now this is the orientation of the septum. This and this you see. Actually, initially you will be having formation of ridges. Later on, that ridges will fuse. So this and this will fuse. So here it is coronally oriented. So this is the coronal septum. So one is anterior, other one is posterior. So at this level, the septum is oriented sagittally. So here. So one is on the right side, other one is on the left side. Right side, what you have is the ascending aorta. Left side, what you have is the pulmonary trunk. Little bit higher level. Once again, the septum is coronally oriented. The ridges are coronally oriented. So if this is getting fused, you will be having that coronal part of the septum. So next diagram, the septum, the ridges are fused. You concentrate this yellow and green. These ridges are getting fused. So the septum is coronal. So your pulmonary trunk is anterior like this. Pulmonary trunk is anterior. Ascending aorta you can't see, it is posterior. Now at this level, the septum is sagittal. So on the right side you have ascending aorta, left side we have your pulmonary trunk. So when telling about this part, as I told, you should be very clear. So for pulmonary trunk also we used to ask development or branches. Ascending aorta also development or branches. Arch of aorta also development or branches. So you can't get any clue from the question for this quarters. So you should be very careful. So for ascending aorta also we used to ask the branches. Yes. Number 133. What are all the branches of ascending aorta? Am I audible or not now? For only
Yes, sir, you're audible,
133, I
sir.
am not audible, it seems. Number 133. Number 133.
Yes, sir.
Am I audible?
Sir, my Wi-Fi is bad, sir. It keeps disconnecting.
What are the branches of ascending aorta? Yes, number 130. Number 130.
Yes, sir.
What are the branches of ascending aorta?
Left subclavian vein, left subclavian artery, right subclavian artery, and no, sir, left subclavian artery.
What is my question?
So branches of ascending arch of aorta.
Hello, Mister. Ascending aorta is different. Arch of aorta is different.
So branch of ascending aorta.
But you are telling about arch of aorta. Still, this and all confusion means you are not a medical student first. No? What is that ascending arch of aorta? Ascending aorta is a separate entity. Arch of aorta is the another entity. Ascending aorta continuous as arch of aorta. Arch of aorta then continuous as descending thoracic aorta. This and all in the school itself people are reading. Now you are in the medical college, you are telling ascending arch of aorta. My question is, what are the branches of ascending aorta, not arch of aorta? No, that too in the aorta you are starting with the vein. This is a very, very blunder mistake. If you give answer like this, definitely examiner will fail you. From one artery you are getting another vein means you are doing arteriovenous anastomosis. Number 125.
Yes, sir.
125. What are the branches of arch of, what are the branches of ascending aorta?
Right and left coronary.
Very good, very good. Is it Srinivas? Who is number 125?
Me, sir. Srinivas here.
Srinivas, very good, very good, very good. So branches of ascending aorta, your coronary arteries. What the previous student enumerated are your branches of arch of aorta. Right, your brachiocephalic trunk. It is not right subclavian artery and right your common carotid artery. Okay, keep it in mind. It is brachiocephalic trunk. So anyhow, you are going to read about the arch of aorta during your next class. Or is it over? Or students, arch of aorta is over or not?
Yes, sir.
Over already. It is over. So keep it in mind. Ascending aorta is different. Arch of aorta is different. Okay. So now you know that how this your septum is formed in the truncus arteriosus. It is spirally oriented, dividing that your pulmonary trunk are not dividing. your pulmonary trunk and ascending aorta are having three different relations because of the different variation of the septum. Initially, it is coronal, then sagittal, then once again it is coronal. That's why we are getting this relation, anteroposterior relation, right and left relation. Then once again your anterior and posterior coronal relation. So that is the spiral septum that separates your pulmonary trunk and your ascending aorta. Suppose if you come down little bit, your infundibulum and your aortic vestibule. So very clearly you can see this spiral septum here, coronal, sagittal, once again coronal. Same thing. We have a video also for the same picture with video. For this formation of your spirally oriented septum, another contribution is neural crest cells. Neural crest cells, they are getting migrated from the neural tube through your pharyngeal arches, reaching your endothelial heart tube. So for proper orientation of this spiral septum, the neural crest cells, they are getting migrated from the developing brain is also important. So that is a recent research. In the recent research they have found out this neural crest cells migrating from the developing neural tube is contributing for proper orientation of your spiral septum. See that here only we are going to get that spiral septum. Initially the ridges will be formed on the here coronally oriented septum, here sagittal septum, here once again coronal. See that? So these are the ridges formed initially. These ridges will fuse. So coronal, sagittal, coronal. So at this level it is coronal like this. At this level it is sagittal. At this level once again it is coronal. So how the blood flow is going. Now we are having fusion of the ridges to form very nice video. So this is your coronally oriented septum, sagittally oriented septum, once again coronally oriented septum. That's why it is spiral septum. So at this level, your pulmonary trunk is anterior, ascending aorta is posterior. At this level, your aorta is on the right side, your pulmonary trunk is on the left side. Here once again, your aorta is anterior, pulmonary trunk is posterior. So that is the formation of your spiral septum. Now, if there is any defect in this formation of spiral septum that is formed in truncus arteriosus, what are all the anomalies we can have? So this already we have seen the formation of your membranous septum. So another common congenital anomaly that is called as Fallot's tetralogy. Fallot's tetralogy. So this is due to improper formation of your spiral septum leading to pulmonary stenosis. So pulmonary stenosis means pulmonary trunk will be stenosed, leading to right ventricular hypertrophy. So already I told descending down of your bulbar septum, lowermost part of spiral septum called as bulbar septum. So that leads to formation of your ventricular septum. So here if there is any defect in that leads to ventricular septal defect. At the same time, the proper orientation of spiral septum is not there, means that leads to overriding of aorta. So what do you mean by that overriding of aorta? So if you have proper formation of your spiral septum, your aorta will be getting originated from the left ventricle. Your pulmonary trunk will be getting originated from right ventricle. So if there is any defect in that, so the part of aorta will be overriding the interventricular septum. So the part of aorta will be opening into right ventricle. Part of aorta will be opening into left ventricle. So that is called as overriding of aorta. So this is common short notes for you. It is tetralogy means 4 defects are there. That's why it is called as tetralogy. So pulmonary stenosis, right ventricular hypertrophy, ventricular septal defect, overriding of aorta. So this is called as your Fowler's tetralogy. So this is common for combination. Sometimes atrial septal defect may be associated with that. In that condition, it will be called as pentalogy. Fowler's pentalogy. But in tetralogy, what we have is ventricular septal defect. See this picture. So this is the normal one. So this is your Fowler's tetralogy. So see the first one, pulmonary stenosis. See that. So this is the pulmonary orifice with the normal semilunar valve. Here you see it is stenosed. So stenosis means narrowing of pulmonary orifice. That leads to right ventricular hypertrophy. See that here this is the right ventricle, normal right ventricle. Here you see the wall, it is hypertrophy. So pulmonary stenosis leading to your right ventricular hypertrophy. Now see that this is the interventricular septum. Already I told it is getting originated from the floor of the common ventricular chamber. Now this is the site of membranous part of interventricular septum. So here the defect is there. So that is ventricular septal defect. Already I told ventricular septal defect is more common in the membranous part. Okay, so now if you see the aorta, so this is ascending aorta getting originated from the your, it should be originated from left ventricle, but here it is overriding. Partly it is opening into right ventricle, partly it is opening into your left ventricle. So all these 4 components may be due to the defect in the orientation of spiral septum, or defect in the formation of spiral septum, or it may be due to the neural crest migration also, failure of migration of neural crest cells also. So that is the common congenital anomaly called as Fowler's tetralogy. Don't forget the components. Fowler's tetralogy or tetralogy of Fowler's, pulmonary stenosis. If you understand the basic, it will be easy for you. Pulmonary stenosis, if you remember, so if there is any outflow obstruction, automatically you will be having hypertrophy. So leading to right ventricular hypertrophy associated with ventricular septal defect and overriding of aorta. Fowler's tetralogy. Another one, if there is failure of formation of septum in the truncus arteriosus, that is called as patent truncus arteriosus. Patent truncus arteriosus. Here you see, so this is aorta. So this is your aorta, this is your pulmonary artery. It is supposed to be pulmonary trunk here, but you see there is no septum here. Okay, so that's why this is patent truncus arteriosus. No septum is formed in the truncus arteriosus, not that patent truncus arteriosus. So this is different. The other one is different. So this is called as transposition of great vessels. Transposition of great vessels. From the right ventricle, we will be having origin of aorta. From the left ventricle, we will be having origin of pulmonary trunk. Okay, so this is called as transposition of great vessels. Great vessels means that denotes ascending aorta and pulmonary trunk. So if that septum is if the orientation of your spinal septum is not correct, that may lead to this defect also. From the right ventricle, we will be having origin of ascending aorta. From the left ventricle, you will be having origin of pulmonary trunk. So that is called as transposition of great vessels. Previous one is called as absence of septum in the truncus arteriosus, called as patent truncus arteriosus. So these are all the some of the common congenital anomalies. So the embryological basis of these congenital anomalies you should know. In addition to these, previously what I told is your ventricular septal defect and your atrial septal defect. So these are all the common congenital anomalies. So that you should know the embryological basis of all these 5 congenital anomalies. So if you go to the clinical side, you are going to see all these patients. So if you remember these things, then you can find out what are all the symptoms, how to diagnose and all. You are going to learn once you go to the clinical side. So that concludes the development of heart and its congenital anomalies. So next topic, very small topic, is the fetal circulation. So now you know about the adult circulation. So few points about our fetal circulation. So what is the difference? Can anyone tell what is the difference between adult circulation and fetal circulation?
Pulmonary circulation does not exist in fetal circulation.
Pulmonary circulation is not established. Very good. So because of that, we have right to left shunt. Okay, very good. Any other point?
So umbilical.
Okay, no pulmonary circulation. So where the oxygenation takes place?
Umbilical. The umbilical artery and umbilical vein.
Placenta.
How in the arterial vein oxygenation will take place?
No, sir. It will be present in fetal circulation.
Oxygenation takes place in the placenta. That's what you have to tell. Placenta is doing that function. Okay, then in that case, how that oxygenated blood is carried to the fetus?
So
How that deoxygenated blood? How that deoxygenated blood from the placenta, from the fetus goes to your placenta? That is the another new thing you should know. Okay, so your umbilical vein. So here also you have that difference. So in the fetal circulation, from the placenta, umbilical vein is carrying the oxygenated blood. Your umbilical arteries are carrying your deoxygenated blood from the fetus to the placenta. So that is the basic difference. As the lung is non-functional, the placenta is doing that function. So for that, placenta needs the deoxygenated blood from the fetus that is carried by umbilical arteries. So if you see the content of umbilical cord, we'll be having 2 umbilical arteries and 2 umbilical veins in the initial stage. Later on, that right umbilical vein disappears in the very early stage itself. So you will be having only 1 umbilical vein, that is your left umbilical vein. The other 2 arteries are there. So these are the contents of your umbilical cord. So your left umbilical vein carries oxygenated blood from the placenta to the fetus. Your 2 umbilical arteries, right and left, carries your deoxygenated blood from the fetus to the placenta. So that is the difference. Another difference, as your lung is non-functional, we have shunting of blood from right side to left side, from right atrium to left atrium. That already we have seen while reading about your formation of intra-atrial septum. So the right shunting of blood from right atrium to left atrium to bypass pulmonary circulation, only we have the formation of ostium primum, ostium secundum, patent foramen ovale. Later after delivery, the patent foramen ovale will be closed. by tight opposition between your septum primum and septum secundum. Now you see this picture. So
Right.
now, yes.
So right side has a more pressure difference of the heart.
That and all in physiology you have to read. So I will
Okay.
tell about the anatomical part. Okay. So now you see. So this is your umbilical vein. So which umbilical vein?
Left umbilical vein.
So this is the left umbilical vein. Carrying, you see that color of blood passing through it. So it is purely red. Here you see, this is your ascending aorta, arch of aorta, descending thoracic aorta, abdominal aorta. Abdominal aorta is getting divided into, yes, terminal branches of abdominal aorta.
So
Common iliac artery.
common iliac artery.
Common iliac.
Iliac.
Common
Right. Yes, right and left common iliac arteries. So from right and left common iliac arteries, we have the umbilical arteries. You see that? So these two are the umbilical arteries. So these two umbilical arteries and umbilical vein are passing through the umbilical cord. So these two umbilical arteries from the fetus carrying the deoxygenated blood to the placenta. Okay, so this one umbilical vein, left umbilical vein, carries your oxygenated blood. So left umbilical vein already you studied. After delivery, left umbilical vein degenerates to form
Ligamentum teres hepatis.
yes, very good. Ligamentum teres hepatis. Where it is lodged?
Inferior border of the
anterior border. Where you can locate your ligamentum teres?
Falciparum ligament.
Falciform
inferior
ligament,
border
not
of
forum.
the falciparum ligament.
In the free margin. So that margin is called as free margin. So your falciform ligament is having anterior margin and posterior margin. Anterior margin is attached to one. Posterior margin is free margin. So in the free margin of your falciform ligament, you will be having ligamentum teres. If you trace it, it is going to liver. So like that, if you trace your left umbilical vein that carries oxygenated blood from the placenta, note that from the placenta, it goes towards your liver. Where what happens? This left umbilical vein joins with left branch of portal vein. It joins with left branch of portal vein. If you see the next picture, you can understand that. So this is the left umbilical vein. So this is your portal vein, right branch and left branch. So at this side, this left umbilical vein joins with left branch of portal vein. So oxygenated blood from this left umbilical vein goes to left branch of portal vein. So left branch of portal, while it is going, you see here 3 arrow marks are given. Mainly that blood goes to one venous channel. Before that, very minimal blood is going to your portal vein. Through that, it goes to the hepatic sinusoid. So very minimal blood goes to liver. But major part of the blood is directly going to IVC through a venous channel connecting your left branch of portal vein and IVC. So that only called as our ductus venosus. So ductus venosus is nothing but the venous channel connecting your left branch of portal vein and IVC. Because of that, majority of the oxygenated blood coming to the liver through the left umbilical vein bypasses the liver circulation, hepatic circulation, and goes to IVC. So from the IVC, already you know that IVC is opening into right atrium. So it goes to right atrium. So now you see already the minimal blood going here and there to the fetus. So through that will be the IVC will be receiving deoxygenated blood also. So at this site, the oxygen saturation will little bit come down due to mixing of this oxygenated blood passing through the left umbilical vein, ductus venosus, reaching your IVC. So minimal reduction in the concentration of O2 will be there. Then this blood reaches your right atrium. So it goes to right atrium. So from the right atrium, already you know that the right to left shunt is there. That's why the blood from right atrium will go to left atrium. So it goes to left atrium. So while going to your right atrium, see that minimal small arrow mark is there. Very minimal blood will mix with already the blood present in the right atrium coming from the SVC, from the upper part of the body. So minimal mixing of oxygenated blood with deoxygenated blood takes place. So minimal reduction in the saturation will occur here also. Note that point. One point at the level of IVC, another point at the level of right atrium. You will be having very minimal reduction in the saturation. So it goes to anyhow majority of the blood will go to your left atrium. So here, so anybody told about what is that? Intervenous tubercle in right atrium? Any teacher told about it? Intervenous tubercle of lower, LOWER. Intervenous tubercle. So okay, no problem. In fetal life, it will be more prominent. So to prevent the mixing of the blood passing through this, your what is reaching the right atrium, that is your oxygenated blood.
Oxygenated blood.
Yes, with the deoxygenated blood, the direction of blood, this blood will be directed directly to the left atrium by a ridge here. So that ridge is preventing the mixing of oxygenated blood and deoxygenated blood. So that ridge is called as intervenous tubercle. Why intervenous tubercle means down we have IVC, above we have SVC. So between that IVC and SVC opening, you will be having a ridge here that is called as intervenous tubercle of lower. So that will direct the majority of the blood to the left atrium. That prevents the mixing of your oxygenated blood further with your deoxygenated blood present in the your right atrium. So, but even then, very minimal blood will go to right atrium. Then from the right atrium, it will go to the right ventricle. From the right ventricle, it will go to the pulmonary trunk. Okay, so that very minimal will go. Now the majority of the blood from right atrium to left atrium. So that's why already we studied here. So initially we have ostium primum for the shunt. Next we have ostium secundum for the shunt. Next we have pattern foramen ovale for this right to left shunt. Till delivery, that shunt is maintained. Now blood from the left atrium goes to left ventricle. Now from the left ventricle, it reaches ascending aorta. Ascending aorta, then your arch of aorta. When it reaches the level of arch of aorta, you have some of the mixing of deoxygenated blood coming from your right ventricle through pulmonary trunk and pulmonary artery through a communication between your arch of aorta and pulmonary trunk. Here we have a communication. So that communication is called as ductus arteriosus. Note that this is ductus arteriosus. What we have here is the ductus venosus. So ductus venosus is connecting your left branch of portal vein and IVC. This is ductus venosus, but this is ductus arteriosus. Ductus arteriosus. So here that communication is between your pulmonary trunk or your left pulmonary artery to your arch of aorta. So ductus arteriosus. So the minimal deoxygenated blood will come to this ascending aorta, sorry, your arch of aorta through this ductus arteriosus. Now at this level you see it is, as it is coming from this right ventricle, the saturation is getting down. So it is somewhat another brown in color. So this deoxygenated blood from this descending thoracic aorta, abdominal aorta, then pulmonary, sorry, your umbilical arteries going to the placenta. So that is your fetal circulation. Okay, so the oxygenated blood from the placenta is coming through the left umbilical vein. Deoxygenated blood from the fetus goes to the placenta through umbilical arteries. So from the color, your bright red is more oxygenated blood, that brown color is less oxygenated blood. So now important point is, from the ascending aorta already you have branches. So those branches are supplying your heart. So your heart is getting your more oxygenated blood. Then from arch of aorta you have branches that goes to your head and neck and brain. So brain is also receiving more oxygenated blood. If you compare your upper limb and lower limb is receiving more oxygenated blood when compared to the lower limb. Why means from the abdominal aorta we have common iliac arteries. Then your common iliac artery will divide into external and internal iliac artery. From external iliac artery we are having our femoral artery supplying your lower limb. So this part, the whatever branches we are getting from descending thoracic aorta, abdominal aorta supplies your remaining all organs of the body. So all those organs are getting relatively less oxygenated blood when compared to your heart, brain and upper part of the body. So that point is important. That's why repeatedly I asked about the branches of your ascending aorta and your arch of aorta. Arch of aorta branches are, yes, anyone clearly tell about the branches of arch of aorta?
Brachiocephalic trunk, left common carotid artery, left subclavian.
Yes, right side we have brachiocephalic trunk.
It divides into
Then your left common carotid, left subclavian. So left side common carotid and subclavian are directly getting originated from arch of aorta. But the right side we have brachiocephalic trunk.
Right common carotid
Yes, very good. Right common carotid and right subclavian. So right and left subclavian directly goes to the upper limb. So upper limb is getting more oxygenated blood. That's why for some time your upper limb will be longer than lower limb at the time of delivery. If you see sometimes, this is the reason for that. After that we will be having changes in them. So now this is your fetal circulation. So once again I will repeat, left umbilical vein carries oxygenated blood. That left umbilical vein opens into the left branch of portal vein. So from the left branch of portal vein, majority of the blood will go to IVC, bypasses the portal circulation through your ductus venosus. So this ductus venosus is the communicating channel between your left branch of portal vein and IVC. So the oxygenated blood goes to the IVC directly. From the IVC it goes to right atrium. From the right atrium it goes to left atrium. From the left atrium it goes to left ventricle. Then through your ascending aorta, arch of aorta, it goes various, through the branches it goes to the various parts of the body. Then it comes down to the descending thoracic aorta. At the junction of ascending thoracic, sorry, arch of aorta and descending thoracic aorta, we have ductus arteriosus. So that through the ductus arteriosus, deoxygenated blood from the left, very minimal deoxygenated blood from right ventricle reaches your arch of aorta. That's why the reduction in saturation occurs here also. After that, through descending thoracic aorta and abdominal aorta, it goes to various organs of the body through the branches. Already we studied what are the branches of descending thoracic aorta, what are the branches of your abdominal aorta and common iliac arteries, all we studied. So through all those branches, the blood will go to the your various organs. Finally, from the your common iliac artery, we have our umbilical arteries. So those umbilical arteries carries your deoxygenated blood once again to the placenta. So where once again that exchange takes place in the placenta, the oxygenated blood once again pass through this umbilical vein, left umbilical vein. Now important point, what are the changes taking place immediately after delivery? Almost most of the things already you have studied.
Ductus venosus closes.
First one is your umbilical arteries. Umbilical arteries are getting closed. Okay, so umbilical arteries getting originated from the iliac artery getting closed. So the proximal part of the umbilical artery persists as superior vesical artery. The distal part of umbilical arteries persist as are getting fibrous to form medial umbilical ligament. All are important for MCQ. So if you take your umbilical artery, so once the delivery occurs, we are going to clamp your umbilical cord. Umbilical cord will be clamped. So while clamping, first structure getting closed is your arteries. Okay, so because you are only deoxygenated blood is going through that. That's why it is getting clamped first. Okay, so now what happens to those umbilical arteries? Proximal part of the umbilical artery persists as superior vesical artery. Already you have studied superior vesical artery. Now the distal part of the artery fibrous to form medial umbilical ligament. What about median umbilical ligament? What is median umbilical ligament? This is median.
Urachus.
Very good, very good.
Obliterated.
Obliterated allantoic diverticulum forms your urachus. So that only forms median umbilical ligament. Don't get confused with that. So this is medial umbilical ligament. Medial umbilical ligament. So next structure getting fibrous is your umbilical vein. Umbilical vein. So that umbilical left umbilical. So in the initial stage, you will be having two umbilical veins, right and left. The right one disappears in the early stage itself. So left one persists. So after delivery, it is getting fibrous to form your ligamentum teres hepatis. So next structure is your, you see here, you will be having tight overlapping between your septum secundum and septum primum. So you will be having complete formation of your interatrial septum. Okay, so that is complete formation of interatrial septum. So tight overlapping will be there. So till delivery, you will be having, even though septum primum and secundum both are formed, the opening will be there. That is called as patent foramen ovale. Patent foramen ovale. So after delivery, after the first breath, your pulmonary circulation is established. So the complete closure of that your foramen ovale takes place by the tight approximation of septum secundum and septum primum. So closure of your foramen ovale takes place. So next change is your ductus arteriosus. So this ductus arteriosus also getting degenerated, become fibrous to form your ligamentum arteriosum. Ligamentum arteriosum. Before that, I forgot to tell this ductus venosus. So the left umbilical vein is forming your ligamentum teres. Your ductus venosus, what is getting originated from left branch of portal vein to IVC, becomes ligamentum venosum. So already in the liver you studied fissure for ligamentum arteriosum and fissure for ligamentum venosum. So that ligamentum venosum is nothing but this ductus venosus. Ductus venosus, what we have in fetal life after delivery, getting fibrous to form ligamentum venosum. So in the fissure for ligamentum venosum, in the floor of fissure for ligamentum venosum, we will be having this fibrous structure called as ligamentum venosum. But in the superficial plane of your ligamentum venosum, you will be having attachment of lesser omentum. So that is important. Lesser omentum is having L-shaped attachment to the liver. The vertical one is to the fissure for ligamentum venosum. The horizontal one is to the lips of porta hepatis. But in the floor of fissure for ligamentum venosum, we will be having this fibrous ductus venosus called as ligamentum venosum. So like that, this ductus arteriosus, what happens? So that is getting fibrous to form ligamentum arteriosum. So that you can see. So next, the next practical after your heart, you are going to read about superior mediastinum and posterior mediastinum. So in the superior mediastinum, you are going to see mainly arch of aorta and its branches. Of course, this ligamentum arteriosum also. So this ligamentum arteriosum extending between the pulmonary trunk and your arch of aorta, or sometimes left pulmonary artery to arch of aorta, you can see. Okay, so that is your ligamentum arteriosum. Ligamentum arteriosum. So these are all the changes taking place immediately after delivery. Okay, so your umbilical arteries are getting degenerated to form medial umbilical ligament. Only distal part is completely getting degenerated. Your proximal part persists as superior vesical arteries. Superior vesical arteries. Your left umbilical vein fibrous to form ligamentum teres. Ductus venosus fibrous to form ligamentum venosum. You will have closure of your foramen ovale, pattern foramen ovale to form complete interatrial septum. Next, we have the degeneration of your pulmonary, your ductus arteriosus to form ligamentum arteriosum. So all these six are closed means we are getting our adult circulations, IVC, SVC opening into right atrium. So deoxygenated blood from right atrium goes to right ventricle. From the right ventricle, pulmonary trunk, pulmonary artery to lung. Then through the pulmonary veins, your oxygenated blood reaches your left atrium, left ventricle, goes to the body everywhere. So that is your adult circulation. So these are all the changes taking place immediately after delivery. So changes taking place in the fetal circulation after delivery, I enumerated. So that concludes our fetal circulation. So development of your heart, cardiac anomalies, and fetal circulation. In this anomaly, sometimes this ductus arteriosus may be pattern, called as pattern ductus arteriosus. Pattern ductus arteriosus, we used to call it as PDA. Another common cardiac anomaly, pattern ductus arteriosus. So as I told already, pattern truncus arteriosus. So that is very, very rare, but this is one of the common congenital anomaly, pattern ductus arteriosus, PDA. So once again, we are going to read about this ductus arteriosus. What is its development in the aortic arches classes? So that is a separate class. After your pharyngeal arches class, I will take that aortic arches also. So that concludes your fetal circulation also. So entire circulatory system is over. So remaining embryology is your development of head and neck, that we will see while doing your head and neck. After 3/4 of the head and neck over means I will start with embryology of head and neck. Okay, are you clear with now? So tomorrow or day after tomorrow, it will this your PPT will be posted in LMS. You can go through it. And now and then I am posting all these recordings in your Microsoft Teams. Of course, I have uploaded all the recordings in the Microsoft Office. Okay, students. Anything else you want? So time is only 3:30. So anyhow, if you have anything, if no questions means we can leave.
Thank you, sir.
Thank you. Thank you.
Thank
So
you, sir.
23rd you have your test, isn't it? So
Yes, sir.
3 hours time, 3 hours are there, but not that entire 3 hours for your writing. You are giving your test only for 50 marks. So from the beginning time, suppose if you are starting by 8:30 means by 10 o'clock you have to complete your test. This is the practice for your university exam. Keep it in mind. So 50 marks means writing time will be 1.5 hours only. So in the university exam, you are going to write for 100 marks. So it will be for only your 3 hours. Okay, so same practice you have to get now also, then only it will be easy for you in the university exam. Yes? Somebody wanted something? So in between you will be having physiology class on the day. That physiology will be between 11:30 to 1. 8 to 11 you can give your test. Okay? Shall I close the meeting?
Yes, sir. Thank you, sir.
Thank you.
Thank you,
Sir,
sir.
Yes.
sir, even ductus venosus will close after birth, sir.
Yes, ductus venosus degenerates to form ligamentum venosum.
Okay, sir.
That's what I told. Ligamentum venosum. It is getting fibrosed to form ligamentum venosum.
Okay, sir.
Yes.